Hello from the Forcetronics YouTube channel and welcome to Maximizing Arduino's ADC Resolution and Accuracy. This is part one and I suspect this will be about a three-part series. In part one we're going to focus mostly on resolution. What is measurement resolution or ADC measurement resolution and how can we maximize it? And we'll also look at a little hint for increasing ADC measurement accuracy. In later parts we'll focus a lot more on accuracy. So what is 10 bits of resolution, or what is any bits of resolution, or what is measurement resolution? Well, if we take these two rulers, that's an easy way to kind of show what measurement resolution is. And on top we have a ruler that measures centimeters and a ruler that measures millimeters. Well, which one has higher resolution? The millimeter ruler does, obviously, because it gives us finer granularity into whatever it is we're trying to measure, whether it's distance or a voltage value. More measurement resolution means finer granularity into whatever the exact value is we're trying to measure. So what does it mean when we have bits of measurement resolution? Well, let's look at a simple example of a ADC that can measure voltages with 2 bits of resolution, and it can measure voltages from ground or 0 volts to 5 volts. 2 bits of resolution basically means we have 4 different states we can measure. And where do we get that? Well, we have 2 digits and they're binary, so there can be a 1 and 0, so we have 4 different combinations. And we can actually see that if we take 2 to the 2 power, we get 4, and 2 means binary, and to the 2 power means the number of bits we have. So if we're trying to measure a voltage that at any time can be between 0 and 5 volts, we basically have 4 different levels that the ADC will detect, and then we can convert that into a voltage. Now, with only 2 bits on a 5-volt scale, we're not going to get very good resolution. For instance, if the signal was at, 4 volts, the ADC is going to return 0.1, which we would translate into 3.333 volts, but really it's 4 volts. So we can see a huge deviation on what we can actually discern with only 2 bits of measurement resolution. Now, most of the Arduino chips, and they vary, but most of them have about 10 bits of resolution. And what does that mean? Well, that means we can discern between 1,024 different levels on our voltage scale. And how did I get that? Well, binary is 2, so I take 2 to the 10th power, and I get 1,024. So that means, if we think of the Arduino Uno, if we have a 5-volt measurement scale for our ADC, which the Uno has, we basically have a resolution of about 5 millivolts or 4.89 millivolts. So that means whatever we measure, assuming that we have ideal accuracy, we will be no more than 4.89 millivolts off from whatever the true value is. Okay, now that we have our overview of what resolution is, or what ADC measurement resolution is, let's look at how we can maximize it in our Arduino. So if we use the analog read function, which I'm sure everybody's familiar with, to make an ADC measurement, what Arduino does by default is it uses VCC as the ADC reference. So the ADC reference determines what the scale is for what we're measuring, and it's also used as a reference. It's used as a comparison to whatever the input voltage is to try and figure out what it is. So what is VCC? Well, if we think about the Arduino Uno, it's 5 volts. It's whatever the input power is. So by default, that input power voltage level is used as the ADC's reference. And I already said that for Arduino Uno, that's 0 to 5 volts. What if we're trying to measure a sensor and it doesn't go up to 5 volts? It's 0 to 2.5 volts is the scale of the sensor. Well, that means we're only using about half our levels to measure our sensor, because we have 1,024 levels in a 5-volt scale. So that means we only utilize about 511 levels or so. And, like I said before, that gives us 4.89 millivolts of measurement resolution. But using a 5-volt scale, we're sort of wasting some resolution. If we could set our scale to match whatever the device we were measuring was, that would give us more resolution. Meaning, if we could match our voltage scale level of the ADC to whatever the device we're measuring, we could get the full 10 bits or 1,024 levels to measure the sensor's output. If we could do that, Once again, if our ADC reference was 2.5 volts, we would get 2.44 millivolts of resolution. So we could get a much more real picture of what the actual value is. What I'm leading up to, if you haven't already guessed, there is sort of a way to adjust our ADC reference. So we can adjust our ADC reference to better match whatever we're trying to measure to get the most out of our 10 bits of resolution. So here's a picture I got from the Atmega 328P datasheet. It may differ depending on the Arduino you're using, but this is meant to just give you an idea. But for this chip, there's basically 3 options for setting the ADC reference. There's the first one, which we talked about, the default, which is using what they call AVCC. And this essentially connects the input reference for the ADC to the power supply of the Arduino. And you can see the ADC voltage is then fed out to a comparator that's in the rest of the ADC circuit. Another option is to use the internal 1.1 volt reference. So the chip generates a 1.1 voltage reference, and we can also use that. So that would be great for measuring lower voltage sensors or inputs. And then finally, AREF, which is actually a pin, if you look on your Arduino Uno, is a way to input some external voltage reference to use for our ADC. And for instance, you have a 3.3 volt output on your Arduino Uno. You could feed that into the A reference, and that would set your ADC reference to 3.3 volts. So 3 different options, and one of the options allows us to set the reference to almost anything. One warning, though, is if you look at this layout, you can see that if you have your bits, which are the bits, if you look in the data sheet, to choose the reference, if you set these to choose, let's say, AVCC, and you have an input here, you're going to short them together. So how do we set the reference on the ADC? Well, we could use registers. That gets a little tricky, but luckily, Arduino IDE already has the function or the capability built in, and a lot of people just don't know about it. The function you'll be using for this is the analog reference function. So you don't need to add any libraries. This is already built in, and I'll show you how to use it, but this allows you to choose the reference for your ADC. Now here's the arguments for the analog reference function. The first is default, and this is what it already starts out as, and so default will use 5 volts if you're using an Uno. If you're using something like a Pro Mini, whose VCC is 3.3 volts, that's what the default will be. You can use internal, so for the 328 pin, or I should say chip, that's 1.1 volts. For some of the other Arduino chips, it's different values. Then these 2 are for the Mega, which has multiple internal voltages. And then finally, we can set it to external, which will allow us to use the AREF pin. Now, of course, the AREF pin can only take a value from 0 to 5 volts, depending on the chip you're using. Now, one thing that's worth mentioning, and I'll show you real quick, is if you want to use an external reference voltage, you can actually get for a very low cost a IC chip to do that, and it'll give you a real accurate output. So here I just did a quick search on voltage reference IC. So let's say you wanted to set your own reference voltage. You can easily get a chip. They're low cost. They'll take some kind of input voltage range, and then they'll output a steady state voltage. Okay, let's look at an example using some of our ADC references to get more resolution, or maximizing the resolution of our ADC. So in this example, and I'll show the code for this and post it on my blog, but in this example, I'm going to compare using the internal reference, which is 1.1 volts, versus AVCC, which is 5 volts, for measuring a voltage level that's less than 1 volt. So as you can see on the left, I used a high resolution DMM to capture the voltage value, and I just picked a random one. So we have 836 millivolts approximately. And so then I made a measurement in my Arduino sketch, switching between the different references, and I printed it out to the serial monitor. Now, one thing we can see right away is the internal reference, the 1.1 volt one, is spot on. Actually, I'm a little surprised about how accurate it is, but that must mean that this voltage level falls really close to one of its levels, I should say, for the ADC. And then if we look at the default, the AVCC, we actually see it measures 828 millivolts. So if you can see, it's about 8 millivolts off. Now, one explanation I will say is you may notice that 8 millivolts is more than the 4.89 millivolts we calculated. That's the resolution we should be getting. But keep in mind, we haven't considered accuracy, and that's what we're going to talk about more in later parts of this tutorial. So that's a combination of accuracy and also resolution. Okay, let's look at the code for the example that I just showed, or the results of the example I just showed. So here, first what I do is I declare some constant float values, and what I'm doing here is I'm actually increasing the accuracy. So VCC may not be exactly 5 volts, and I measured it with the DMM and I had 5.049. So I hard-coded that in. Also, the internal reference wasn't exactly 1.1 volts. You can see right here what it is. So to increase the accuracy, I actually measured the reference values and hard-coded it into the sketch. I start my serial communication and then I go into my main loop and I delay for 1 second. Then what I do is I set the analog reference to default. So I'm using VCC as my reference. I then call this function that burns 8 readings. And the reason I do this is when you switch to internal, the datasheet even tells you that the first couple of readings typically aren't accurate. So I just burn 8 readings to be safe when I change from one reference to the other. I then print this out, this message. I'll start here. I then do an analog read on A0 because that's where my voltage is coming in. I feed that into a function called convert to volt. So I'm feeding in the reference value along with my analog value to convert it to a voltage value. And then I use this 3 to tell them to print it with a precision of 3 decimal places. I then delay again. I then set my reference to the internal one. So this is 1.1 voltage reference. I burn my 8 readings, so I know that the next reading will be accurate. I print something out. I then do the same thing, but this time I'm feeding in the internal reference value and printing the voltage there and 3 decimal places of precision. So let me show you the 2 functions real quick. Here is the burn 8 readings, and that's just simply burns 8 readings or makes 8 readings and does nothing with them. Here is my convert to voltage value. So, and this is right out of the data sheet, but I take my measured value, A value, I convert it to a float, I divide it by 124, or I should say 1024, I then times it by my reference value to get the voltage value. Okay, so that's the code. I will mention that I also did this example using the registers, so I'll post that to my blog as well in case you want to check that out. I should mention, what if your voltage that you're trying to measure is much higher than the ADC reference? Well, you can use a simple resistor voltage divider to bring down the voltage to match your ADC reference. And I've talked about voltage dividers in other posts. What if your voltage is very, very small? You may not want to match your reference to a very small voltage level. What you probably would want to do there if you were trying to measure a very small voltage level is to use an amplifier such as an op amp, which that's a whole nother tutorial, but an op amp would be a way to go to boost that real low voltage sensor value up to a higher voltage and then measure it with your ADC. Okay, that's it for part 1 of increasing or maximizing Arduino's ADC resolution and accuracy. Go to my blog for the code that I showed you as well as the register-based ADC code. Stay tuned for part 2. Please, if you enjoyed this, subscribe to my YouTube channel, and if you have any questions, you can email me. Thank you for watching.